Hi, I'm James Verdier, and welcome to the American Institute of Biological Sciences BioScience Talks, which is a forum for integrating the life sciences. On the second Wednesday of each month, and often in between, we discuss the latest bioscience publications. And as a reminder, if you'd like to read more, point your browser to academic.oup.com/bioscience. Today's episode is the next in our In Their Own Words oral history series, in which we talk with scientists who've made great contributions to their fields, particularly in the biological sciences. This week's guest is Paul Ehrlich, who is president of the Center for Conservation Biology and Bing Professor of Population Studies Emeritus at Stanford University. He's also a past president of AIBS. Let's go straight to the discussion. Dr. Ehrlich, thank you very much for joining me today.
Pleasure to be here.
When did you first know that you wanted to work in the life sciences?
Well, I can't really remember when I didn't. I was very interested in nature when I was a kid. My mother was, and my father was a businessman. My mother was an intellectual who encouraged all kinds of interests. And I was sent to a Boy Scout camp where there was a nature program, and I got interested in nature. And eventually, in a camp summer, I was introduced to butterfly collecting. And through a friend, I went to the American Museum. I was living in North Jersey. I went to the American Museum of Natural History and was introduced to Charles Michener when I was 15, who was then the curator of Lepidoptera. He was the world's greatest expert on bee taxonomy and the behavior of social insects, but the only job he could get getting out of Berkeley was to be curator of Lepidoptera. And he conned me into mounting butterflies for him by giving me, for my butterfly collection, specimens from around the world without data. And he encouraged me to join the Lepidopterist Society, of which I suspect I'm now the oldest living charter member. And that was when I was certain I wanted to go into science. It was not clear to me until I, through the Lepidopterist Society, by the way, got to spend some summers in the Arctic. I was very interested in Arctic alpine butterflies. And I was also very interested in anthropology and living with the Eskimos for about 4 months one summer, working for the Canadian Defense Research Board and Department of Agriculture. I almost went into graduate school in anthropology, but I decided butterflies were better. And so I guess that it was meeting Michener that determined me that I wanted to go professionally into science.
That's interesting. What was the draw of anthropology to you?
Well, I learned a non-Indo-European language, part of it, and was able to observe the way the acculturation of the Inuit was going. I learned to admire the Inuit and to appreciate their sense of humor, and tried to learn as much as I could about their culture. I put together, still have it, maybe one of the first dictionaries of Inuktitut, the Inuit language, in my field notes for that summer. And so I found human behavior fascinating. I still find human behavior fascinating. Although we're involved in the AIBS, I think the real action in science today has to be in the social sciences, anthropology being one of them. And I have tracked anthropology and written on anthropological and psychological topics a lot over my career. So I always interested in science. And the big worry with the butterflies was whether I'd be able to make a living at it. Should I go into business like my father had and make enough money to live on, and then have 2 weeks a year of vacation to work with the butterflies, or should I risk starvation but go professionally into working in evolution and taxonomy, which is what I was thinking about at the time, and take the chance of starving?
Okay, so you decided to take that chance of starvation and follow butterflies. What was it like at that time starting out a career in science?
Well, it was exciting from a number of points of view. First of all, I was very lucky. I went to my parents could afford to send me to an Ivy League school. We weren't rich, but we weren't poor either. And my father was willing to put up the tuition, which wasn't as ghastly proportionally as it is now. And I ended up rooming with several uh, veterans of the Second World War. And so I got very much involved in discussions of politics and of the environment. And I and several of the others read books by William Vogt and Fairfield Osborne on the environmental problem of those days, and we used to argue about it. Meanwhile, I went to the museum in Philadelphia, the Academy of Natural Sciences in Philadelphia, where James A.G. Wren, the curator of Orthoptera, and Ruth Patrick, who was a young, then starting up biologist, and met those people. And Wren let me become the volunteer curator of the butterfly collection there. And a friend that I had met through the LEPSOC, through the Lepidoptera Society, Nick Gillum, who later had a great career as a Chlamydomonas geneticist, if I recall correctly. He and I published a couple of papers in butterfly taxonomy. And so I had a sort of semi-scientific career there. This was all, of course, in the days before the NSF and the big injection. I mean, it was a start of the time when a lot of money was injected into science following up on the scientific aspects of the Second World War. So all of my buddies at Penn were in the zoology department, were going to be doctors. They were pre-meds. And fortunately, Rudolf Schmieder, who was the editor of the Entomological News, was a Penn faculty member who encouraged me in my butterfly work. And he helped arrange through John Fogg, who was the provost, associate provost, I think, of the university, to get me to leave Penn early 2 springs to go to the Arctic, because Tom Freeman was running the Northern Insect Survey. And I had met him at the first Lepidoptera Society meeting. And one thing led to another. I ended up working in the Arctic, having wonderful adventures, or sometimes not so wonderful. And when time came to go to graduate school, at the Entomological Society of America had its annual convention in Philadelphia. I think it must have been in 52, because I graduated in 53. And I tracked down Michener at the meeting, and he remembered me, and I gave him reprints of a couple of my papers, and I said that although I had spent my undergraduate days drinking and chasing women, I had continued my work with butterflies, and would he give me a chance to go to Kansas, where he had become chair of the Ent department, so he could work on bees, and I'd show him what I could do. And I also applied to Cornell, which was the biggest Ent department at that entomology department at that time. And Mitch accepted me. So I wrote a letter to Cornell withdrawing my name as an applicant. And they wrote me back a letter saying, it's a damn good thing you withdrew your name, because we wouldn't have accepted you either. And that actually gave me great pleasure later on, because Tom Eisner, who hopefully everybody in the AIBS knows, was a good friend of mine, and invited me to give, many decades later, a distinguished lecture at Cornell. And Tom had been turned down by Cornell for an undergraduate career, although he was on the faculty there for, I think, probably 40, 50 years. And he was able to introduce me and say that both of us had been refused entry into Cornell, which was a nice moment.
Yeah. And so what would you say is the biggest surprise of your career?
Well, the biggest surprise of my career, uh, the biggest single and most important surprise of my career, came at Kansas when I was a graduate student and working on my dissertation was a phylogenetic study of the butterflies, the higher classification of the butterflies, which had been largely, I'd gone to Michener and said what I'd like to do for a dissertation is a revision of the Satyridae, which was the group of butterflies that occurred commonly in the Arctic and Alpine zones that I had collected and worked on in the Arctic and so on. And he said, why don't you, the butterfly higher taxonomy is all screwed up. Why don't you do a study of the higher classification phylogeny of the butterflies? And being, of course, an egotistical kid, like I'm an egotistical adult, I thought, sure, the bigger the better. I should mention here, by the way, it should get somewhere into the article that I had a huge debt to Michener and that I met him when I was 15 and we were still friends when he was, I think in his last year, he was 94 and I was 82, something like that. We had maybe the longest friendship of a student and faculty and mentor in the history of biology or close to it. Mitch was absolutely wonderful, and he got me an assistantship at Kansas with Bob Sokol, who brought statistics into biology, and we had a seminar, Michener, Sokol, myself, Jim Chilcott, who I had met in the Arctic, but we were discussing evolution, taxonomy, phylogeny, that sort of thing. And Bob said one day, this is all about the surprise, he said, you guys aren't studying phylogeny, you're just putting things together according to their similarities. And the rest of us, Mitch, me, Jim Chilcott, Earl Cross, said, that's bullshit. We are studying the phylogenies. And Sokol said, no. He says, if somebody just measured the characteristics of, say, 50 or 100 characteristics of your organisms, you could then do a correlation coefficients and come out with what you call a phylogeny, but which is really just a dendrogram showing the similarities. And we said bullshit. And we argued about this for a couple of weeks, and then Mitch and Sokol decided they had to put it to a test. And the test was that Mitch got one of his graduate students to put in, say, 100 different bees and measure 100 different characteristics, either measure them linearly or say big, small, or fuzzy, not fuzzy, and so on, and gave Sokol 100 lists of characteristics. And Sokol, who was the perfect controlled experiment, Bob didn't know a bee from a butterfly. He was a theoretician. And he went away and did product moment correlation coefficients among the different numbers and put them in, devised a way of making a dendrogram out of it, a tree-like diagram, and came back to Michener, and Michener had to agree that not only had he produced a proper phylogeny of the bees, but he had correctly placed a couple of parasitic species that Michener felt he had misplaced originally, and that was the beginning of numerical taxonomy. And I was stunned because there was something that I had thought I was absolutely right on. A test was run and I was shown to be absolutely wrong. And that's a good experience for any scientist, I think. Everybody should have an opportunity to be shown really dead wrong. I've had many subsequently, but that was the first and most stunning surprise I got. My other surprises are things like finding out how stupid I'd been when I got together with a an orthodontist, and she pointed out to me that there was some evolutionary problem in the fact that all the kids around had to have braces in their mouths, and it never dawned on me that that is really evolutionarily a funny thing, and to this day, orthodontists still think that that is somehow, quote, genetic, end quote, even though that's absolutely nonsensical. So I'm often surprised at the conservatism of scientists. There's people still write papers on how to define species, even though that problem was totally solved in the 1960s by papers by me and Sokol and Carvalho. But they keep at it. So scientists are like other people. They can be extremely conservative.
So how did you go from that, that early study of insects into, looking at questions of, human population and the carrying capacity of the globe and those types of things?
The transition there was partly due to my assistantship with Bob Sokol. That's what Mitch got me, an assistantship working on the evolution of DDT resistance in Drosophila. And quickly, it was wonderful from my point of view to actually see selection at work in the lab. In 10 generations, you can make fruit flies totally resistant, basically, to DDT. And in 10 generations of SIB selection, you can make them drop dead if you say the word DDT. And the implications of that, for example, for antibiotic resistance and so on, were crystal clear to us in the early 50s. The interest in evolution was my central interest, and in a way still is, in terms of my, and most of the stuff on population and so on is not in any way deep intellectually. There are deep intellectual questions related to evolution, obviously. But when I got the job, I ended up getting a job at Stanford. There's a story there too, but it's probably too long. But when I joined the department in 1959, the chair said to me, and it's the only instruction I've ever gotten from Stanford, having been on the faculty there for something like 60 years and now being emeritus, he said, "Could you teach a course in entomology and one in evolution?" And I said, yes. And so I started teaching an evolution course on a quarter basis, which meant there was 10 weeks of course and 3 lectures a week. And for the first 9 weeks, I lectured on evolution, where we had come from. And the last week, I lectured on evolution, where we were going. And the course became very popular, and particularly the last week. And I began to get requests from, particularly through Stanford's alumni program, to talk to people about the environmental situation, which was basically where we were going. And I started doing it. And through some alumni, I was invited to talk to the Commonwealth Club in San Francisco. And I did not know at the time that talks at the Commonwealth Club were often broadcast on a series of radio stations. And so I talked at the Commonwealth Club. The topic was the food from the sea myth, the biology of a red herring. And it got a lot of attention from the radio, and I talked a lot about the population side of the issue. And Dave Brower, who was then at the Sierra Club, and Ian Ballantyne, who invented pocketbooks, paperback books, came to me and said, "Could you put down the things you're saying in that lecture in a short book, and maybe we can change the results of the election, get this injected as an issue in the election," which was coming up, Lyndon Johnson running. That would have been 68. And Ann and I wrote the book in a week of evenings, and that's where the population bomb came from. And a celebrity of the time. It sent the book to Johnny, liked it, sent it to Johnny Carson. I got asked to do the Tonight Show. It was after we had, so I had started with Charlie Remington, who was who was the founder of the Lepidopterist Society at Yale, and an attorney. We had started the organization ZPG, Zero Population Growth, and Johnny let me give the address on the Tonight Show, and it led to the largest flow of mail ever into the headquarters of ZPG, which at the time had 6 chapters and 600 members. And by the time I'd been on the Tonight Show 3 times, it had 600 chapters and 60,000 members, which showed me the power of the mass media.
Yeah. How have you enjoyed doing that sort of outreach over the course of your career?
Love it. I mean, if you're a born loudmouth, when you can talk to 50,000 people at one time or 5 million instead of 50 in a class, you love doing it. And it has, of course, it has some downsides, like the threats and so on. But the upside is, if you get that kind of notoriety and you're a field biologist, you get to go to places that you ordinarily couldn't possibly go to. In other words, it led, for instance, to a career in cruise lecturing. You said you'd never been on a cruise. Everybody predicted I would hate being on cruises. Actually, I loved it because the deal normally was, if I'd give 2 lectures a week, they'd take Ann and me, and sometimes Ann, me, and our daughter Lisa, on a cruise. And 2 lectures a week for a loudmouth who teaches all the time is absolutely nothing, and yet you get to go to places which are financially out of your reach and often fantastic. And I got to travel all over the world through cruise lecturing on ships and through Stanford having a travel study program, which you lecture to Stanford faculty, but leads to things like around the world flights, going to places like Korea and Taiwan that I normally would never have gotten to, but all over the world. So that, as far as I'm concerned, being a public scientist had huge benefits, as well as, of course, some disbenefits. But on a ship, I hate to tell you, when you're not occupied lecturing, you can do whatever you damn well please, and that means often reading and writing. You have your own cabin. You don't have to repack every night, if like you do when you're traveling or doing field work, moving, as we have done. It's just wonderful. It's an opportunity to be very productive in wonderful circumstances, and you can do your hour walk on the deck early in the morning to get your exercise, watch flying fishes if you want to relax. And during the day, your big decisions are where to eat lunch, whether to go to movies after dinner, when to make love. I mean, it's a tough life.
Sounds brutal.
It is terrible, but thank God I had guts.
So a question about being a public scientist now versus when you began that journey. Do you think it would be harder now than it was then because of, things like social media, the openness to a greater degree of criticism from various circles? How has that changed over the years?
I don't know. It's very hard to say. The criticism, I was very lucky. There was, of course, associated with the population bomb, an enormous amount of criticism, including a lot of threats. But first of all, I believe, and I think most scientists believe, that you live by your reputation with other scientists. Ann and I have always been very careful, if we have a new idea or something, to try and get it into the peer-reviewed literature. The population bomb, for example, was read by a whole bunch of top scientists, including Peter Raven, Don Kennedy, who later became the editor of Science, the head of the Food and Drug Administration, Stanford's president, read it. So when I wasn't, as long as I knew I wasn't out on a limb, I don't mind being heterodox within science, but I always want to be in a position where scientists recognize me as heterodox, maybe wrong, but possibly right. And so I've been fortunate that way. And I was also fortunate in being able to be one of the first, thanks largely to Johnny Carson, um, to be able to address very large audiences on central mass media. Uh, the Tonight Show had audiences of tens of millions. I did it more than 20 times, I think, all told, and I did a whole series of similar shows. And I really, John and I used to have a really good time. I found it very enjoyable to do those things. And today, that I don't think I've seen a scientist get the kind of time I got on the Tonight Show recently on any of the, central media. But there are all the blogs and so on. The trouble is to penetrate in that area is very difficult. A good example currently is everybody's focused on the coronavirus. The coronavirus, of course, is something all of us had predicted for years in detail. But no attention is being paid to the much more serious problems, like a little bit is being paid to climate change because we're seeing the results of climate disruption now. But the things like the toxification of the planet, the fact that human sperm counts are dropping precipitously. In one study, I saw there's a prediction that by 2050, the average sperm count in the West will be zero. This stuff is being ignored, even though we have these huge existential threats, not the least of which is nuclear war and large-scale nuclear war. So at a time when we need scientists speaking out even more, it's tougher to find the platforms on which to speak. I have not seen a single thing, and Anne watches the news all the time. I don't think she has either. A discussion of what the refusing, that is F-U-Z-I-N-G, of our nuclear triad has meant to the stability of the standoff with the Russians, the nuclear standoff, and the chances of an accident or non-accident large-scale nuclear war, which would end civilization, which we, of course, went into detail in the 80s with the nuclear winter studies. But that's not even mentioned these days because of the focus on the bungling of the pandemic. And as I said, actually, to a group in the National Academy not long ago, I think every scientist nowadays' main duty, if they're not working on trying to solve the many open issues on the coronavirus, on SARS-2, should be working to get rid of the thugs in the government, particularly Trump and the people who are enabling him in the Republicans in the Senate. Anybody who thinks that science in the form that most of us would like to see it is likely to persist in any form if Trump is reelected or refuses to leave office, I think is just whistling in the dark. And so I think it's a duty of scientists to get out in the public and not just talk about how to deal with the epidemic, which, of course, as I said, is being totally bungled, but also make the parallels to what happened in Germany in the early 1930s and so on. Scholars have a responsibility to inform people, and boy, we sure have failed in the educational system to get people aware of the existential threats to our society, and that goes for Stanford University too. Stanford, Harvard, and Yale are all pathetic in this area, and you can get all the way through Stanford as an undergraduate or even a graduate student if you don't take the right courses and not know what the second law of thermodynamics is, what the second law of thermodynamics is, what an ecosystem service is, what the size of the human population is, and what difference that makes, and so on. Have I raved at you enough now?
No. I'm going to encourage you to do more. Do you think the problem there is, shortcomings of present practitioners of science who aren't getting out there enough and doing enough and saying enough? Or do you view it as, a structural issue in which, we no longer have the media outlets that are mainstream, in which, people can come out and raise alarms about, broad issues like that? Where are our big shortcomings coming from?
Well, I think part of it is structural, no question about that. And part of that, all sorts of structural issues which are complicated, and I can't even give you a full answer to. One night, Robert MacArthur and I had a long, drunken discussion. At least I was drunk. I don't remember whether he was or not, over whether the NSF had been worth it. In other words, steering science and steering it into big science has led to some things like much too much emphasis on the medical sciences cure areas, much too little on the environmental and prevention areas, and so on. But would we have been better off if there was no NSF? And then how would the research have been done? It's interesting that when I first came to Stanford in 1959, there were still big issues of how science could interact with, for support, with business and with the military. And that has somewhat faded away, maybe faded away too much.
So a little earlier, we were talking about professional societies, or you began as speaking about them at the earlier parts of your career. I'm wondering about what sorts of roles they've played, and it occurred to me that one of the points you were just making about the relative spending on medical science versus ecosystem science is a point that you one point made in 1990 in a publication in BioScience.
One of the things that bothered me at the time, and in a way still does, was the success of the AMA, the American Medical Association, in getting huge amounts of support for medicine, basically, which I wasn't against getting huge amounts of support for medicine. But then, as today, I considered the health implications of what's going on environmentally to be even more serious than the needs in medicine at the time. If the climate gets 3 or 4 degrees warmer, the public health consequences are going to dwarf the SARS-CoV-2 pandemic. In a sense, the main medical advances we have made are primarily getting clean water to a lot of people and keeping mosquitoes away from a lot of people, and so on. We put huge effort into taking care of old farts like me with very expensive procedures and so on. It's not clear that that's the best way to go. On the other hand, we could probably afford it if we didn't waste gigantic amounts of money on military experiments. The balance of idiocy that we now face with the Russians, for example. The situation today, I think, is much tougher for young scientists than it was in my day. First of all, there weren't so many scientists. There wasn't the need to spend a lot of your time writing gigantic grant proposals. You had, if you were lucky enough to get access to the media, it was a big deal and not competed against. In other words, there were very few major outlets and so on. But today, of course, you also have other ways of spreading the word and the social media. I mean, I tweet, even though I don't know how many people ever see the tweet. I do it in support of the mob, the mahb.stanford.edu, which is an organization designed to get the civil society focused on the big existential problems. And it's very effective in one way. That is, a lot of people got involved, but it doesn't seem to have any impact. And one of the things that I find very distressing and disappointing is how hard it is to have any impact on the system the way it's designed now. And to be really pessimistic, I don't think we're going to solve the problem without a huge change in human culture. The whole issue of how people should be educated, what the responsibilities of people are. We are a small group animal, as I've said many times, that's struggling to try very rapidly to learn to live in large groups. And we've utterly changed our environment. We've brought Stone Age genes into a McDonald's world, and it's not working out well.
So you still maintain a lot of the same concerns and pessimism that you've had for most of your career.
I'm much more pessimistic than I was earlier, because until Ronald Reagan, I thought we'd been making progress too slowly, but progress in the right direction. Reagan started to turn it around, and then you end up with things like Trump. And maybe it's impossible to reasonably govern or have cooperate 300 plus million people. It must be just, if we were still after all, we spent most of our history as hunter-gatherers, and in groups of, depends on who you read, but let's say averaging around 100, later on with connections to other groups, but early on with very few connections. And those were groups of people who spoke the same language, who were genetically closely related, who looked alike, had a common culture, and so on, and where leadership went, in most cases, to the person who was best at doing what needed to be done. The hunt leader was one person. The person who dealt with sickness was a woman who had spent a lot of time with herbs and had a memory of, say, where the best water holes were, and so on. And now we have a totally different system, and much of it traces to the idea of personal property, and that people could be personal property. And we still teach mostly bullshit in our histories of what's happened in the world. It's mostly not about what's really happened. It's about kings and who fought whom and who won whom. There's a wonderful book on racism by a psychologist at Stanford named Jennifer Eberhardt, called Biased, which I think any scientist who wants to work in today's world and have some impact on our culture needs to read, because I found, even though I have worked for my entire career on issues of equity, I organized with Ralph Barr sit-ins to desegregate the restaurants of Lawrence, Kansas, when I was a postdoc there. I even found myself rethinking my own biases in that book. There's also a PBS series which Ann and I watched just recently of about, I think, six 1-hour shows called Liberty, the American Revolution, which actually told much of the real story of the American Revolution, what they were after, who they were, and so on. I've always recommended to my students that they should read the Federalist and Anti-Federalist papers, at least sample them, because the problems the 13 colonies, which were really separate states, faced after the war was how to get organized so they could retain their distinct characteristics and still work together to solve their overall problems, like how to keep the British away and so on. And it's exactly, in a sense, the same problem that 195 separate states are trying to solve globally, where they want to remain distinct in many ways, but they can't solve problems like climate disruption, the loss of biodiversity, global toxification, one at a time. It's got to be solved by everybody, and we haven't found a way to do it.
So it's a case in which, we see the same problem repeated 200 years later, but on a slightly different scale.
On a larger scale, and we're still working with the same species. Unhappily, we followed the cultural course that the chimpanzees took, whereas if I had been back there several million years ago, I would have voted to follow the bonobos. In other words, we solve our problems by threatening people with nuclear weapons or blowing them up with conventional weapons. The bonobos solve their problems with genital rubbing, and that's my way of going.
So do you think that these large scale problems are solvable through cultural evolution, or do you think that our behaviors are ingrained and we're somewhat destined to face these issues?
I think we know perfectly well that we can solve these problems, at least in theory, through cultural. First of all, we obviously don't have time to solve them by genetic evolution. People have often said things to me like, well, look, if fruit flies can become resistant to DDT, why should we worry? We can just become resistant to DDT. And I always say, yeah, in 10 generations, that's about 200 years. If you just kill 98% of human beings by poisoning them with DDT, you'll probably have a population that's quite resistant at the end of that. People don't understand that generation time is the key thing in biological evolution. But look, most everybody in the United States manages to override one of our main ingrained genetic urges, and one of the central ones, that is to maximize your reproduction, and culturally doesn't do it. You can have 10 kids, but very few women I've talked to are planning to have 10 kids, or men. In fact, most of them are planning to have one or two, which is one is right or zero better, but 0 or 1 better. But nonetheless, we see around the world that cultural evolution can overwhelm the most ingrained of our habits. And most of the stuff that says DNA is driving our bad behavior is just people who are fascinated by DNA but don't know the numbers. There's just all kinds of crap out there, including that our jaws have been shrinking rapidly, particularly over the last 300 years, because of genetics. Is that it happens wherever people industrialize, or actually starting with agriculture, and who in the world would think that in 300 years there would be heavy selection for small jaws? Well, or can it be drift? If it's drift, how come it drifts in the same direction in any culture that becomes industrialized? In other words, the lack of knowledge of how evolution works and so on should tell everybody that if we're going to change our ways, we got to change them with cultural evolution. And the issue of how to do that's why we formed the mob originally. The original title of the mob was the Millennium Assessment of Human Behavior. And Ann and I set it up with Don Kennedy, who was, I think, then president of Stanford, in the idea being that we had in the Millennium Ecosystem Assessment discovered that the ecosystems of the planet were in deep trouble, which, of course, most of us already knew. And what we didn't know was why we weren't doing anything about it. And that's why we had the idea of having a Millennium Assessment of Human Behavior, rather than more looking at how rapidly things are going downhill, trying to figure out how to stop them from going downhill. And we've, of course, failed there. At the moment, for example, the Trump administration is doing everything it can to make the existential threats closer and worse. And they're succeeding.
So do you see a greater role, if we were to get ourselves out of some of these, dire conditions, a role for organizations like scientific societies, groups of scientists, those in the know, to collaborate and work together to improve education? It sounds like would be one of the linchpins of a successful project.
Absolutely. Human beings are social animals. And there's a lot of evidence in the psychological literature that groups can solve problems easier usually than individuals. Doesn't mean that some extraordinary individuals don't get great ideas, but if they're not picked up by groups, they don't get implemented. generally. So I think it's very important. I mean, I have, as you know, had, as for example, why I went into the AIBS was to try and make the groups more effective at what they do. I think one of the problems is there's still a hangover from the shoemaker stick to your last thing, that if you're a scientist, you only can talk science only in your most narrow field and not have any opinion on what society ought to do about your scientific results. I think we're slowly but surely getting rid of that, but there's still enormous pressure, pressure in the wrong direction. For example, I tried to convince the Ecological Society that they should pay more attention to the social sciences, and I actually got a group of distinguished social scientists to give them that message at one of the meetings. Had no impact. The 100th anniversary of the Ecological Society was coming up, and a group of people, not including me, tried to get them to focus it on population, because demography is the most neglected thing because of various pressures in the overall picture of why we're going down the drain. And they basically refused. They asked me to try and intervene, and I tried to intervene by saying, why not hold the meeting in Washington, D.C., where the media might pay some attention and focus on all the things that ecologists think are being neglected relatively in our social discourse. And they wouldn't do that either. They held the meeting, the 100th anniversary meeting in Baltimore, that media hub, and it was on the great achievements of the Ecological Society, but that doesn't mean that there aren't huge advantages to having the sciences. I loved going, when I have the chance, to scientific meetings, because I want to see my buddies and drink with them rather than just, do it over email. But of course, we can stay in closer touch now. The meetings face-to-face seem to be less important, although I still think the face-to-face is very important for scientists. And I've been lucky because I've been able to travel around a lot and see colleagues, and colleagues come here, at least until the pandemic.
And how has that the pandemic experience, been for you? It sounds oppressive right now. You're dealing with wildfire smoke, and presumably,
yeah, it's been hideous. Anne and my social life, our pleasure, has been for many years, for decades, having dinner with colleagues and friends in restaurants and drinking wines that we're interested in. And now I think it's something like 26 weeks we haven't been in a restaurant. We've seen our friends, with a couple of exceptions, only in 2 dimensions on the screen. When our granddaughter drove up from LA, she's a statistical consultant, we couldn't get her into our building. We had to see her only outside, and we couldn't take her to a restaurant. We had a dinner with some close friends with masks on, social distancing at the end of a driveway in smoke. But the most disheartening thing is we're in good shape. I mean, we're in an air-conditioned building where we have just got air purifiers, which are helping with the smoke. But being retired, we still have an income. Many people around here don't have an income. People that we knew well, for example, in favorite restaurants, they're closed, and the people that work there are out of work. People are hungry in the United States. The people dying, sick, and unemployed because of the total unbelievable incompetence of the Trump administration is a constant pain for me and many of my colleagues. It was there was in the government from the last administration an organization designed to deal with possible pandemics, and Trump closed it before the pandemic came along. So I feel like I'm in Germany in 1931 or 2, seeing the parallel things which are destroying not only our democracy, but I think in even the medium term, probably destroying human civilization, because I don't see any path at the moment, even if Trump is removed, that is likely to take us away from the growth path, which is taking us to a collapse of civilization. But I don't see any choice but to keep trying.
And for those, I'm thinking particularly of young scientists. What advice would you have for them in terms of navigating these difficult times?
Well, my first advice always to people wanting to go into science is don't do it if you don't love it. In other words, people have often accused me of being a workaholic, which is super silly, because my hobbies were being out in nature, collecting butterflies, watching birds, that sort of thing. And that's what I do professionally. And I love doing it. So why in hell shouldn't I do it? So first of all, love what you do. Second of all, don't wait until you're fully established before you get involved in the political issues. Get involved early on. It's advice I gave many years ago to John Holdren, who at the time I met him was a graduate student in working on plasma physics, world's expert in the potential environmental impacts of fusion, generation of power, and many other things. But he started early and went on to become the top advisor a science advisor for Obama, de facto science advisor for Clinton, worked with the Russians on all sorts of environmental problems, was central to the American response to the Fukushima thing, worked very hard on scientific relations between the United States and China, and did brilliant work on the confinement of plasmas, and also in environmental issues in general. And so he's the living proof, even in those days when there was a lot of the stick to your last crap, that a young scientist can have a real impact even before he or she gets fully established. And I give other examples too. So I think do great science. You will if you love it. And then always focus on how it impacts the really big picture. Science is an absolutely critical part of our civilization now. We have built ourselves into that, and therefore scientists should pay great attention to other things besides what is strictly science. Science tells us that racism is nonsense, but just knowing that it's nonsense is nowhere near all that needs to be done. Same thing on nuclear weapons, for example.
Well, I think that's a very strong message and a good note on which to leave the conversation. Dr. Ehrlich, thank you very much for joining me today.
My pleasure.
And that concludes this episode of BioScience Talks. Just a reminder, the journal BioScience is published by Oxford University Press on behalf of the American Institute of Biological Sciences and is made possible by the support of our members and donors. Thank you, and talk to you next time.